Example 1. Shown are the salaries of 12 mathematics textbook editors and thousands of dollars. So there you go. Construct a box and whisker plot of this data. So, first thing I want to do is I want to arrange the data in numerical order, smallest to largest. Looking, I can see 18 is the smallest, followed by 19. Next one up looks like 21, then 23. Oops. Helps to cross off the right number there, 23. Looks like 24, 25. If a number happens the same twice, write down both, they both count. That's not happening in this problem though, so we get 27, 28, 29. And then 31, 33, 35. Okay, to make a box and whisker plot, I'm looking for 5 specific numbers. I'm looking for the minimum, first quartile, second quartile, third quartile, and the maximum. Okay, the min and max I think are self-explanatory. The smallest number on the list is 18. The largest number on the list is 35. Okay. For the sake of the box and whisker plots we're going to be dealing with a number of data points that divides evenly by 4. I wouldn't give you one that doesn't divide evenly by 4 right now because those are a little bit more complicated, but for right now, expect to divide it by 4. So, how many salaries are there?
12.
And 12 divided by 4 is? 3. So if I chop this off into groups of 3, first 3, next 3, next 3. The second quartile is just the median. It's the same median we've been finding since lesson 45 of this book. It's when you line the numbers up in numerical order, it's the halfway point. And if there's an even number of data, it's the average of the two middle numbers. So the average of 25 and 27 is 26. The first quartile is just the median of the first half of the data, or it's just the average of these two. 21 and 23 averages 22. And the third quartile is just the median of the second half of the data, 29 and 31, which would be 30. All right, so that's all the quartiles are. It's just the median, and then the median of the first half, and the median of the second half. Once we've done that, all that's left to do now is to establish the box and whisker plot. So here's how it works. We've got 5 points here. I'll use different colors to represent them. So the minimum number is 18. So I find 18. I'm going to go. There's not like a y-axis here, but just kind of go in the middle. So I've given you some graph-looking paper here. 18 lies right there. Then I got Q1 is 22. Q1, I'm going to put a dot there also. Q2 is 26. I'm going to put a dot there also. 22, 3, 4, 5, 6. Q3 is 30. Put a dot there. And the max is 35. We'll put a dot 31, 2, 3, 4, 5. Right. Officially, we're supposed to establish if there's any outliers. If there's one data point, let's say it was like 18 all the way to 33, and then this was like 560. That'd be an outlier. Okay, but we're going to stay away from outliers for right now. We're just going to stick to simple box and whisker plots. Okay, the way it gets its name as far as a box and whisker plot is concerned is we create a box around the quartile 1 to quartile 3. Like so. We put a vertical line at quartile 2, and then we put a horizontal line out to the min and max. And I also identify these things as what they are. That's what my box and whisker plot should look like for that. So again, looking at this chart, as far as interpreting it and reading it and getting information from it, I can tell immediately that the halfway point is 26. The halfway point of the first half of the data is 22. The halfway point of the last half of the data was 30. The maximum score is 35. The minimum score is 18. I also know that 25% of the data lies between 18 and 22. 25% of the data lies between 22 and 26. 25% of the data lies between 26 and 30, and 25% of the data lies between 30 and 35. So that's kind of what a box and whisker plot gives you. It gives you halfway points, max and min, and quarter of the data is here, quarter of the data is there, out like that. So that's basically what we're going to get out of a box and whisker plot when we do graph it, or if we've got one graph for us and they say interpret it, that's kind of the interpretation we can get out of it.